Alright everybody, welcome back to 3 Deviations. In this video we're going to be talking about the product rule. This is really going to start our study of more advanced differentiation, where we're going to be trying to build up our knowledge so that we can take the derivative of any function. So in the last video we talked about taking the derivative of monomials, and we could expand that to radicals as well as polynomials with the sum and difference rule, and the fact that radicals are just rational monomials, rational exponential monomials, sorry. And we can build on that by talking about taking the product of two polynomials or two monomials with the product rule, and then we'll expand this to other types of elementary functions later. So first, let's talk about one of the misconceptions with the product rule. The product rule is not just f prime times g prime. That's what at first, one of the founding fathers of calculus thought, Gottfried Leibniz. He thought that it was just f prime times g prime, but it turns out that because multiplication is a little bit more nuanced than addition and subtraction, we needed a more complicated formula. And this seemed weird to him because with limits, with our limit property for multiplication, we could just say, okay, we're just going to separate these two limits. We'll take the limit of f and the limit of g, and then we'll just multiply our results. That's not how it works for differentiation. We need a new formula for the product. So this is what the rule says for the product rule. So given that we have the functions f of x and g of x, the derivative of the product of f of x and g of x is f prime of x times g of x plus f of x times g prime of x, or the derivative of f times g plus f times the derivative of g. And it doesn't matter which function we choose to be f and which function we choose to be g. I usually like to have f be the function closest to the left and g closest to the right. And then I like to make a little table so that I know what I'm going to plug into my formula here. So that's the power rule in its purest form. And as you'll see later, we can expand this so that we can have more products, and we'll just end up having more combinations of functions, derivatives, and functions as well. All right, so let's do an example. So let's say I want to take the derivative of 3x squared times 10x. So this is something we could easily just multiply these two monomials, and then we could use the power rule. But to see how the product rule works, we're going to use the product rule on this. And again, I like to start by doing a little table, little scratch work, so that I know which functions I'm going to be plugging in. So I'm going to choose f of x as 3x squared and g of x as 10x. So f of x is going to be 3x squared, and then the derivative of f is going to be 6x, basic power rule. Then g of x is going to be 10x, and then the derivative of g is going to be 10, again, just constants. All right, so now we have all of our information to just plug it into our formula. So we're going to get 6x times 10x plus 3x squared plus 10. And when we multiply this out, we're going to see that we can just add these like terms, 60x squared plus 30x squared equals 90x squared. So the derivative of 3x squared times 10x is 90x squared. And again, if you want to try with the power rule, you can. I'll show you what's going to happen. We're just going to multiply this. We'll get 30x cubed. And then when we want to take the derivative of that, that's just going to be it's just going to be 3 times 30x to the 3 minus 1 power. And that's just going to be 90x squared. And that's what we got down there. So the product rule and the power rule both work. All right, so now let's do a more complicated example, which again, you could just distribute, but I mean, who likes distributing? Why don't we just use this nice rule that we have now? So if I plug this in again, what we're going to do is we are going to make our little table here, and we'll get f of x is equal to x minus the square root of x, because I'm choosing this to be my f of x, and then my g of x is going to be x plus square root x. And then if we take these derivatives, we're going to get 1 minus 1 over 2 root x for f, and 1 plus 1 over 2 root x for g, f prime and g prime, not just f and g. And if we plug this into our formula, we get 1 minus 1 over 2 root x times x plus root x plus x minus root x times 1 plus 1 over 2 root x. So that is our product rule formula. We've got it in place. Now all we need to do is some algebra. This is some tricky algebra, but it's going to end up nice. We're just going to get a nice linear. We're just going to get 2x minus 1. So the derivative of x minus root x times x plus root x is 2x minus 1. So that is our derivative. Just did a nice derivative there. All right, now we're going to do a more tricky example. I talked about the product rule having kind of an expandability to it if you have more than one or more than two functions that you're multiplying. That's exactly what we're going to do here. We're going to take the derivative of x squared plus 2 times x cubed plus 1 times x minus 9. And so the original product rule is the derivative of fg is equal to f prime g plus fg prime. But now what we're going to need to do is we're going to need to expand it. So we're going to do d over dx of fgh, and that's going to be f prime gh plus f g prime h plus f g h prime. You can see how this is going to fold out when we start getting even more terms, even more little functions that we're multiplying. We're just going to keep having more combinations here. So that's really how the product rule works when we want to take more than two functions. All right, but let's try this example here. So I'm going to make my table. It's going to come in handy a lot now. So we'll have f of x. This is going to be f of x. This is going to be g of x, and that is going to be h of x. So f of x is equal to 2x squared plus 2. And through the power rule, my derivative of f is going to be 2x. And then g of x is going to be x cubed plus 1. And then g prime, through the power rule, is going to be 3x squared. And then h of x, which is x minus 9, my derivative of h is going to be 1, because we just have x here. When we reduce that power, we just get 1. So we have everything set up. Now we're going to plug it in, and we're going to need to do a lot of foiling here, and then some more distribution after that. We get 2x times x cubed plus 1 times x minus 9 plus 3x squared times x squared plus 2 times x minus 9 plus x squared plus 2 times x cubed plus 1. And note there's no coefficient here because h prime is just 1. So I guess I could put 1 there, but that doesn't really help our cause. So now we have everything out. Now we just got to do some algebra again. And we will get 6x to the 5th minus 45x to the 4th plus 8x cubed minus 51x squared minus 18x plus 2. And that is our derivative. Thank you again for watching this video. Next time we will be talking about the quotient rule and how we can take derivatives of rational functions. See you guys soon. Please like and subscribe. Thank you very much.